All right, Mitch, you're on deck now.
Good evening, everyone. Um, so hopefully we're going to get some more rain. And as Tom had mentioned earlier, we got a number of forays coming up this weekend. I imagine hen should start coming up soon. So hope for the rains, and we can get out there maybe the weekend after that and see what we see. Anyway, I'll jump right in. This was submitted by David Lee. I don't know if he was out there, if he had some friends out there. But you may kind of recognize the look of this mushroom, but it's not really looking the same color as what we're used to. And that's what first struck me when he sent these to me. I was like, that doesn't look right. And I was unsure, so I did a little research and go ahead, advance. Looking at them, you'll see you've got a yellowish mushroom with kind of almost like brownish, darkish fibrils all over it. You've got this very pale hymeneum. So that's where the ridges are, deeper ridges than you would see in our area. If you didn't notice, this is in the Mount Rainier area. And so this clearly is a chanterelle, but not a chanterelle that we would find around here. There are a number of different species of chanterelles that we may not see. Even the West Coast chanterelle, the golden chanterelle, can be different than the one than we find here. And if you're out looking for chanterelle, sometimes you'll find some that have like a whitish stipe and much deeper ridges. And so we have a number of regular orange, larger chanterelles, not just the smooth chanterelle. Anyway, I believe this may be Cantharellus cascadensis. It tends to have a yellower coloration and a much paler hymeneum. I thought that seemed like a very cool lime. They're pretty hefty mushrooms too, and they're only found over on the West Coast. Next. All right, David Lee also sent this guy in, and unfortunately in our area, we would not find these either. I believe I did find some little baby guys when I was visiting Ohio on a work trip one time. They were tiny little guys. I don't know why they were so small. These typically are very large because they grow on a couple of different mushrooms. Typically, something like a Russula brevipies was a big white mushroom. That's really not worth much, and it has this kind of like tapered little tiny stipe. That's the brevipies, the little foot, and that turns what is normally a kind of blah mushroom into this tasty edible mushroom. As you can see, they tend to be quite dirty when you find them, so I'm sure they're a mess to try and clean up. But this is a mushroom mold attacking a mushroom, and it's known as the lobster mushroom. This is Hypomyces lactiflorum. All right, David Leaf sent this guy in too, and this was in our area, and I was kind of unsure what to call this. If you see that membrane there on the bottom of that mushroom, it looks very agaricus-like, and that's going to be your partial veil. And usually those would also, if it's an agaricus, have a dark spore print. And if you see those mature mushrooms over there, I'm trying to point with my with my mouth. You can see the underside. Those are pretty mature mushrooms, and they still have white gills. At this point in their life, if those were agaricus, they would have brown gills. There are a number of lepiotas that can look like this. I know of Rubro tincta, but it tends to be much smaller and it has this red center. And in fact, a lot of the cap surface can be relatively white and as it grows, the scales break up and you've got that white undersurface showing. Looking this up, it could be Rubro tinctoides, but I think that may be a West Coast mushroom typically. But considering that veil, I'm wondering if this is actually just a Leucoagaricus. Leuco is white, and so it's an agaricus type mushroom. Looks very agaricus, but it has white spores. But I am actually unsure what to call that one. Anyway, I thought it was interesting. All right, John found this guy in Port Deposit, Maryland. He said it was like 12 feet up in the tree. And you may recognize it. We've had that on this little in your neck of the woods show a couple of times, and I'm sure you've seen them around because they're fairly common mushrooms. One thing about this one is the stipe is typically those pores run down, and you'll see they look like they truncate right where it joins the stipe. Um, I'm not sure what's going on with that, but he wasn't even able to get these. This is why you only see shots of the bottom, but you can see that scaly top showing. This is, well, it used to be polyporous squamosis. Now it's serioporous squamosis, or the dryad saddle. Um, and if you have seen some of the little orange guys recently, those used to be polyporous mori, and they've changed those to serioporous. They're the hexagonal pored polypore. And if you think about how that one looks and how this one looks, they're fleshy. They're not that super leathery polypores, and they have a similar cuticle structure on the cap, the top, and the pores. These are much smaller pores, but if you think about them, they're very similar. So it kind of makes sense that this has been put to seriopores. I'm sure there are other molecular data that I am unaware of, or microscopic data. But anyway, on a more as a layman, maybe you can kind of tell. All right, Maryland submitted this guy, and wow, is that not a beast or what? Um, uh, that's probably a foot across. Uh, you may be able to tell it's a bolete, but if you advance, you'll see on the underside, yes, it's got pores. It's got some yellow staining. She's got another one of its, I guess, brothers or sisters, to show the scale of that big one. You can see a lot of bugs have been in there, bruising the pores and turning it blue. I'm not sure if I've got the name right. Giving it a good whiff would probably help. But considering the pale color, the kind of faintish blue, I thought this might be Lanmoa pallidirosia. That's normally called the beef bouillon bolete. And so if you were to smell it, it would kind of smell a bit like actually a lot like beef bouillon, in my opinion. Um, this is an older mushroom. I can't be certain that's what that is. It could be some sort of other overgrown of something else, and that's caused the color to go a little paler than it normally would. But anyway, that's my best guess, just offhand. All right, so I am a government employee, and so I was furloughed, and I actually have been taking my bike out and riding around a little bit and kind of enjoying my time, spending it out in the woods a little bit. Um, I was very excited to find this guy because if you see in the background there to the right of the screen, there's some dark coloration. That's actually a big older version of this exact thing. And that is usually how you find it. This old dried up husk of a dark thing under some pine trees. So finding one that's nice and fresh and beautiful like this I was really happy to see this. And actually, Bowie State University is right down the road from me, so I took the BNA trail and just decided to circle the campus just to see what was going on out there. Um, so after I flipped it over, you see, okay, this is definitely a polypore. It's fleshy. Um, and if you zoom into the pores a little bit, advance, you'll see they're not true like real pores. They're not very deep. They're almost mazy, not quite mazy, not quite muraloid, which is if you remember those pink ones that we find sometimes, they've got this real wavy iminium, almost kind of chanterelle-ish. Um, it's also very fleshy, and you'll see that it has this dark staining. So this is actually the dye maker's polypore. It's always growing from conifer. Uh, Baeolis schwinitziae, uh, and they use it to make, I believe, brown colors and things of that nature. But anyway, fun to find this in a pristine state, and it's a beautiful mushroom. Yeah. All right, so I found this one. I believe I may have been at Patuxent in one afternoon, and I always like finding this one and also the one that kind of looks like it just because of that real crinkly cap. And so it's kind of hard to discern, but this would have a dark rusty spore print. It's got this super wrinkly cap. The gills can be a little purpler when they're or kind of reddish purplish when they're younger. Um, uh, you can't really see a rusty ring zone, but this would have those rusty brown spores. This is actually a Cortinarius. It's Cortinarius corrugatus, and the corrugation in the cap is where it gets its name. There is a Satharella that looks very much like this, but Satharella have more of a black, purple black spore print. And considering the age of that mushroom, it would be getting to be almost black. They also have a little bit different texture to their flesh when you see them. And it's probably a little bit thicker than this, but it has a very similar corrugated cap like that. That would be Satharella like delineata or Rugocephala. I'm not sure what the name they've got on it now. All right. Also found in the same area, this was growing near conifers. Always like seeing a little cluster. And before I turned that one over, which you can see, you've got a little striking, uh, like they look like little brownish, orangish brown mushrooms. Oh, let's see what they look like underneath. Go ahead and advance. Boom. Just beautiful red gills. This is actually another in the Cornarius. And you might see a little bit of a rusty ring zone there. Cortinarius tend to have cobwebby gills, which we'll see better in a minute. Um, but I believe this is Cortinarius semisanguineus, which I think also can be used as a dye mushroom. The one that's commonly used is sanguineus and sanguine. I believe that's like blood. And so it's like this blood red gills, blood, and the sanguineus is actually much redder on the top as well. And so if this was redder on the top and also had those red gills, this would be sanguineous. So this is like sanguineous, or at least partially like sanguineous, but no cortina visible there. All right, that's okay. We can move on. All right, so seeing a couple of cortinarius there, I thought this might be a good time to go back over what to look for when you are hunting for bluets. And bluets are a uh, often purple mushroom. Uh, you can see here, both of these are relatively tan mushrooms. They both have purple coloration in them. Cortinarius tend to have a cobwebby cortina or partial veil. And so before the cap opens, and um, you may see that, you may not. That usually leaves remnants, and as the spores mature and turn that rusty brown color, they'll start dropping off. Whoops. Um, um, and but as when bluets are young, they can be quite purple. There are also a couple of different species of bluets that there's one that's called the field bluet that kind of starts out tan. There's even one called the brownet, which is like all brown and doesn't really have any purple coloration. Um, but as bluets age, when even like the Lepistanuta or Clitosabinuta now, they will start turning this tan coloration. They'll start losing a lot of that beautiful violet color in them. And so something you can also look at is the attachment of the gills. I know this, I haven't zoomed in very closely. Bluets tend to have attached gills, but they're notched. And so there'll be like a little notch before they're attached. So it almost looks like there's a little free zone before it touches, whereas Cortinarius tend to attach directly to the stipe or stem. Um, so looking at those two, I think you can probably tell. Oh, I guess I could talk about the top too. So the surface of Cortinarius tend to be more silky and velvety, whereas the cap of a bluet tend to be glabrous. I guess these can both be considered glabrous, but it's much more smooth, often relatively translucent. It doesn't really have any kind of fibrils or anything like that. Um, and so I think you could probably tell by now which is which. And so you can go ahead and advance to the names. You've got your Clitostomi nuda on the left, and what possibly might be Cortinarius alboviolaceus on the right. And so there are a number of these purpley Cortinarius. They're always going to have rusty spores. So if you're concerned, take a spore print. They also tend to have very bulbous bases, although bluets can often have quite bulbous bases as well. And just to make things a little more confusing, you can advance. You've got your Lacaria ochropurpurea. Oftentimes, these will have a darker, instead of this tan color brown on the cap. We found a whole lot of these at Sequinota, and we often do. They do have much thicker gills, probably a little bit wider spaced, almost waxy, like it almost is almost like a waxy cap. They're also attached, and oftentimes, looking at that Cortinarius to the right, they'll have more of a color of that color on the cap. But when you look at the underside, with those thick, wide-spaced gills, it's pretty easy to distinguish. And also, if you go back to your old spore print, this guy is going to have a light spore print. The bluets will have kind of a pinkish spore print, like the Michaelis pink, kind of buff, whereas this one tends to be usually more white. If you get that rusty brown, don't mess with it. This was a cool one. I don't know that I found this guy before. Also, towards the back of Bowie State, there's a number of pine trees back there. And I took a little walk around and I noticed this guy growing directly out of a pine cone. So go ahead and advance. Flipping it over, I saw this really amazing rhizomorphic mycelium that's very prominent, just right there at the base. Really cool. I thought that those little guys under it were just little primordia. Yeah, pine can be antifungal, but there are a number of mushrooms that have figured out the enzymes that they can just chew through all that stuff and it doesn't bother them. So mushroom enzymatic processes are quite amazing at breaking down things. And so I had to look this one up. I wasn't certain of that one. This is actually a Baospora, which I think typically will grow on pine cones. They call it the conifer cone cap, Baospora myosura. At Sequinota, we often find a Strobelurius, which apparently there are Strobelurius that also grow on pine cones. But considering the gill structure and this very prominent rhizomorphs at the base, I think that this is the Baospora myosura. Conifer cone cap. That was a fun find. This is another one found out there. There were a number of these. You can see some are getting a little bit older. And some of you with a little more experience, you might recognize those as, hey, they kind of look Amanita-like. So go ahead and advance to the next one. Looking a little bit closer, you'll see it's got some radial lines along the cap. And some of them had radial. Apparently, one of the things you can kind of look at in these is the radial lines in the cap. And some, they usually tend to stick to a specific distance. You'll see to the left of this, they're about 25%. Here, they're about 50. So it's kind of hard to say. And sometimes that is one of the features they might list in trying to put a name on things. This looks like something in the Caesaria section, the Caesar group of Amanitas. Caesar mushrooms tend to have a very distinct vulva sac down at the bottom. And so when the mushroom is still a button, it's covered in this universal veil. And you may know some Amanitas that vulva ends up breaking up and leaving remnants on the cap. Sometimes it's powdery, sometimes it's patchy, sometimes it's a big patch. Sometimes it's very membranous and they poke right through. So it's almost like it's growing out of a little turtle shell or snake egg or turtle egg. Um, they tend to have relatively yellow gills as opposed to the white gills, sometimes orange, depending on the species. You've got a partial veil, which also is typically colored, and oftentimes you'll have coloration on the stipe. And if you'll advance one, um, the mushroom that I think this might be is typically known to grow with oak trees, and this was a pretty heavy conifer area, although there were some, you can see there's an oak leaf right there next to it. So I'm not certain, but one of the features is it has like a 25% of radial lines. It has a very thick vulva, saccate vulva at the base. I kind of call this pattern on the stipe almost herringbone-ish. And so you've got these different mottled colorations of the yellow and the white. Um, I think most of the ones I found have something like that. The typical um, American Caesar that we find is Jacksonii, and that has a very bright red, orange color to the cap. It has orangish gills, orange like of this pattern on the stipe and all this. And this one's clearly more of a bronze brown, yellowish coloration. And so I think there is some maybe Amanita beningiana, but it's definitely in the American Caesar group. I'm not certain on that, but that's kind of cool. Tom was talking about Mary Elizabeth Banning earlier, and that's what this one's named after. But anyway, that's one of your American Caesar mushrooms. And I thought this one fit right in with the topic tonight. Um, uh, Elizabeth Axley, is that she's the one who submitted this, and she found this in Wisconsin. She's doing some work out there, and I was not familiar with it, but you can see this is an INAT observation, and a number of people agreed that this does look like what she's called it, which is Claviceps zizaniae. Advance. And so you can see the sclerotial formation. This is what you would call an ergot, but this is the ergot on wild rice. And so ergot is known to cause ergotism. And back in the day, people were eating this stuff and it can cause convulsive symptoms. It can also cause gangrenous symptoms due to vasoconstriction. And so it kind of constricts the blood vessels and there wouldn't be enough oxygen. And then they'd start having their feet getting all these blisters and falling apart and all fall off. Anyway, it was not a good thing. But now we've learned that, well, if you use these things in a restricted manner, and the dose makes the poison, right? They've actually turned these into some medicines, and so that vasoconstriction can stop migraines in some, and also to stop hemorrhaging bleeding in pregnancy after you have your baby. They'll give them something like this. I don't know if they've advanced, but they have used that in the past. And another thing it has is a lysergic acid in it. And so Albert Hoffman, when he was doing a lot of research on ergot, actually used one of the alkaloids from ergot and transformed it into what we now know as LSD. And so there's a huge number of alkaloids that are in this, and a lot of them do different things. And some of them are relatively psychoactive, but you certainly wouldn't want to eat this because of so many of the other bad symptoms that could happen from eating it. But anyway, I'm not sure if this one has that exact alkaloid, but I thought it tied in pretty well with the topic tonight. So another psychedelic compound was actually developed from a fungi. Claviceps zizania. Zizania is the wild rice genus. So anyway, thanks for the submissions. Doug Miller sent this from the Milwaukee Museum.